Welcome to Cranfield University, where you are the guests of the Centre for Life Cycle Engineering and Management. My name is Andrew Starr, and I'm going to introduce you to the Railway Robots team. You find us here on location at Cranfield's Railway Innovation and Test Area, where we undertake work in collaboration with Network Rail and other railway partners. We're going to show you one of the series of vehicles that we have used for demonstration of survey, measurement and repair technologies on the railway. I'd like to remind the audience to post their questions on the chat. And now I'm going to pass over to Musume, who will give you an introduction to the demonstration.
Thank you. Hi, everyone. The purpose of today's test is to demonstrate the usability of this robotic system for the railway track inspection and repair task. The main component of this robot is Warthog from ClearPath company. This robot has a number of sensors such as RTA GPS, RGBD camera, 3D LiDAR, and an IMU and a velodometer that they are embedded in the body of the system. As you can see, in front of the vehicle, there is a universal arm, and at the end of the arm, we have a rest camera that is used for defect detection and close-range inspection. This vehicle can move on the ground, and but because of the size and the type of the wheels, it wouldn't run on the railway track. So we have designed and fabricated a trolley in order to transform the Warthog into a rail vehicle. After shifting the vehicle on the trolley, by the movement of the wheels of the Warthog, it will force the trolley wheels to start moving. So in this way, the whole set will start moving. Today, we are not going to detect the real railway defect. Instead, we have a dummy defect, as you can see here. And each of these QR codes have messages. And based on these messages, the arm would have different poses. In terms of the inspection test, first, by the time that the vehicle receives the command, the arm will go to the inspection pose. And in a way that the camera can capture the defect on the railway track. The vehicle would start moving, and by the time that the camera captured the defect on the railway track, the vehicle would stop. And then the arm would actuate poses and will capture from different angles. And then for further processing, we will use those images. Now I will hand over to Feiyang for showing the demonstration.
Thank you, Masumi. Hello, this is Feiyang. We can see the robot is standby on the track, so we can start the demonstration. So firstly, the robot is adjusting its robot arm to make sure the camera can capture the images of the rail. Now the robot starts moving. It's running on the track autonomously. We can see the robot is approaching to one QR code. Oh, the robot detected the QR code, so it stopped. The robot arm poses at different directions, so it can capture the images of the QR code. The demonstration is finished. Let me hand over to Adi. Adi can introduce more details of the robot.
Thank you, Feiyang. It's nice to be here. I'm Ade, a researcher at Cranfield University. So I'll be speaking about the ROS component and how the AI integration for autonomous systems is being developed. The Warthog has got different sensors and actuators. And within the sensors and actuators are embedded the system algorithm that processes these functions to allow it to work autonomously. So we've got the LiDAR, which is a device that releases beams around the environment. And these laser beams quite pick signals around the environment, send signals into the ROS component to detect obstacles. Also, we have the GPS sensor. The GPS picks localization protocols from the satellite and tells us the geoposition where we are. It's used for navigation purpose, and you can program the autonomous system to have a local station and a destination local station, and can also return back to base. So we have also the environmental camera. This camera will pick up the environment and also send the signals into the ROS component, which will be used to pick up defects and also identify obstacles, also identify parts and of the environment, which can be used in the AI algorithm and process for navigation. Also, we have the depth camera, which is just an environment, a local camera, which is useful for picking up environmental signals and recording videos of the process. So these all sensors and protocols are designed and developed within the ROS2 component, and it is in fact a very useful tool to assess all the IO systems. I'll hand over to Jian and Mesume for demonstration of the obstacle avoidance and also the GPS navigation. Thank you.
Hello everyone at Robot Life. I'm Jian Li. I work on the software development for this robot. This is our latest railway robots and automated bench trolley. It has similar feature as the Warthog robot we talked before. The main difference is it's railway ready. It has the wheels ready to go on the railway track without any conversion. Today, I'm going to show you an example of collision avoidance with the LiDAR sensor. Our LiDAR works by sending beams 360 degrees to the surrounding environment up to... Hello, this is Jian. I will repeat the demo we did moments ago, but this time I'll share the screen of the Linux machine embedded within the robot so you can see what does the robot see. As we can see, the camera is pointing at randomly, and it will move to the side of the track, look for defects, which will be represented by QR code. Now I'll hand over to my colleague Fei-Yang.
Yeah, so the robot starts moving again. In real scenario, this camera can be replaced by any other equipment, such as ultrasonic testing kit or any other maintenance kit. So this robot can autonomously do the inspection and maintenance and the repair work. Oh, the camera has detected the QR code. It looks like the second round is finished now.
Well, I don't need to do this because it will be Mifta doing it. So those were our demonstrations. Please keep posting your comments and questions in the comment section. We will answer them as soon as we finish. So just to conclude, to summarize, we have seen how an array of sensors can help an autonomous vehicle like this one to navigate, in this case, around the railway and reach the desired position. Also, how a sensing element, which in this case was simulated using that camera, can be used to detect defects, in this case, just QR codes for the purpose of the demonstration. And also in terms of actuation, we had the robotic arm that was mimicking or simulating the action that can be performed to repair the railway once the defect has been detected, such as performing a weld or performing some mechanical action on the rail itself. So now we'll take a look at your comments and questions in the comment section, and we'll provide the answers. Thank you very much, and thank you to the whole team for this presentation. Thank you. Okay, and then last bit. So thank you, Mifta. I think it is that. And keep your questions coming, and we will be answering those very shortly. So number one question is something technical answer, blah, 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 something regulatory. Yeah, that'll be maybe in 5 or 10 years' time on The Real Thing. How does the GPS work? I'll hand over to Mizume. How does the LiDAR work? Hand over to Jan.
How do you deal with areas that are where GPS is not available? How do you deal with the areas where GPS is not available?
I use the trackside objects as a reference.
Yeah, what you have to say to the camera. Not to me.
Yeah. Yeah, it's a good question and worth rehearsing. I think that's our challenge, is we don't know what the general public are going to ask. Could be really simple, could be quite complicated.
The answer should be, I was explaining that in the video, you should have paid attention.
Okay, I think that's a wrap.
Yeah.